Okay. Hey ladies and gentlemen, this is Miss Humbert here, and today I'm going to be doing Unit 6, Notes 1, talking about the geometric mean. So we're going to learn how to find the geometric mean between two numbers, and we're going to go about doing this kind of by using what we learned with similar triangles. So let's go ahead and let's take a look at what a geometric mean is. So it's proportion used to compare two equal ratios. Okay, so we're going to learn some words. So this A right here, we're going to call an extreme. This B right here is also an extreme. Okay, then each of our x's there represent the mean. So notice that the x shows up twice and it shows up on opposite sides of the fraction. One's in the numerator, one's in the denominator on both of the fractions. So the mean is going to represent the altitude. And we're going to learn what altitude means in a couple minutes here. Okay, so notice that x is on here twice. So we're really going to be using that altitude idea twice. Okay, so when you're setting up the proportion, this is called the geometric mean of the extreme. So basically we're finding the geometric mean of those extremes. So one thing we notice when we're solving fractions like this, we learned last unit to solve fractions like this, we need to cross multiply. So we get x times x is equal to a times b. So we get x squared is equal to a times b. Now if we wanted to solve for the geometric mean, we would have to take the square root of both sides. So then we get that x is equal to the square root of a times b. Okay, x is equal to the square root of a times b. So that's how we would go about doing that. So let's go ahead and take a look. First of all, with just some straightforward, here are some numbers, calculate the geometric mean. If you wanted to on number 1, you could go through and set up the proportions. 8 is an extreme over the mean, and 10 is an extreme. Or sorry, we want to put a mean over the extreme and the other one. You could go about setting it up that way, or you can use that formula we just wrote down, that x is equal to the square root of a times b. That's a lot easier. Because all we're going to do is say that x is equal to the square root of 8 times 10. Well, 8 times 10 is 80. So x is equal to the square root of 80. When you punch that in your calculator, you end up getting 8.9. So the geometric mean between 8 and 10 is 8.9. Let's find the geometric mean of 9 and 4. So again, x is equal to the square root of 9 times 4, which is equal to the square root of 36, and the square root of 36 is 6. Okay, so that's your final answer for number 2. Let's take a look at what an altitude is. Okay, so this isn't it's on your note sheet, but we're going to kind of draw it on your triangle you have there. So altitude is a segment drawn from the vertex of a triangle perpendicular to the line opposite. Typically this right here is a right angle. So this line right here represents your altitude. So that's what that word meant when we were talking about that earlier in the note video. So let's talk about using geometric mean with right triangles. If the altitude is drawn to the hypotenuse of the right angle, so we're going to cut through that right angle and go straight to the hypotenuse, then two triangles are similar to the original and the other. So here we have 3 similar triangles. We have one that is here, one that is here, and one that is here. So what I'm going to do is I'm going to label this point D, and I'm going to call this length H. We'll take a look at that more on the next slide, but let's write out our similarity statements. So what I like to do when I write out the similarity statements, I actually like to write out the triangle itself, and I put it in the corner. So when you're doing these, I do want you to write out all 3 triangles, and here's how I suggest you do that. You put the short leg on the bottom, and you put the long leg going up, and then you put your hypotenuse here. So then when you set it up, it's really easy to identify. Your right angle is always going to be in that lower left corner. So for this first big triangle, we have C as our right angle, and then C connects to our short leg here and our long leg here. Now let's write out our medium triangle. So we're going to put the right leg down in the right angle down in the corner. Now the bottom here connects the short length, which is D to C, and then the long leg is D to B. Next, let's take a look at our mini triangle. So again, our right angle is here, and then here our short length is going to be A. So D to A is our short length, and D to C is our long length. So if CD, that line cutting through the middle, is the altitude, now we've set up our angles. So I'm going to first write this triangle as BCA. And that can be similar to this triangle, and I'm just going to go around the triangle the same way. That's why it's nice that we set it up that way. This triangle is also going to be similar to that triangle. So BCA and then CDA, because B is going to correspond with C. That's why I wrote them out the way I did, so I could just look at the triangles as I'm going around it. And last but not least, triangle BDC is similar to CDA. Okay, so we set it up that way. So that's going to help you guys set these problems up moving forward. So let's take a look at how this applies to geometric mean. So we have our altitude here that connects the point D with the line H. So the altitude drawn by hypotenuse of a right angle separates the hypotenuse into two segments. So let's call this first segment X and this second segment Y. So again, remember that triangle I built for you earlier. I said you should do short and then long and then the hypotenuse. Okay, so let's draw out our three triangles with the sides. So our first triangle is the whole big one right here. Okay, so our right angle is C, and then we're going to connect to the short side, which is A, and this is length B. Our hypotenuse is length C, or you could look at that as X plus Y, and then our long leg is length A. Next, let's take a look at that next rectangle, or sorry, that next triangle. Let's take a look at our medium one here. So our short leg is going to be length H. I'm just going to focus on the lengths right now. My long leg is length Y from here. My hypotenuse always sits across from the right angle, so that's A. Okay, then let's take a look at this guy right here, this little one. So when we take a look at the little one now, okay, my short length is X, now my long leg is H, and my hypotenuse is B. So we're going to set up a proportion, and what it's going to be is it's going to be the short leg over the long leg of one triangle, and then the short leg over the long leg of the other triangle. I'm going to pull the two that use the altitude. So taking a look at this guy right here, my short leg here is H. My long leg here is Y. My short leg of this triangle is X, that's going to go on the top. My long leg is H. So notice I have these two Y's sitting opposite each other. That means I've correctly set up the geometric mean. Okay, so let's take a look at another theorem now. So the geometric mean or leg theorem, the altitude drawn to the hypotenuse of the right triangle separates it into two segments. Okay, let's get this all set up. We call this X, call this Y, call this H. So now, just like we did before, we had those three triangles set up on the previous page. So I'm just going to quickly draw them since we already set them up on that last page. So we have our short leg, which is B, our long leg C, and then our hypotenuse. Our hypotenuse is C and our long leg is A here. Then for this one, our short leg is H, our long leg is Y, our hypotenuse is A. Then for this one, our short leg is X, our long leg is H, and our hypotenuse is B. So now we can also set up proportions such that we can do our hypotenuse over our short leg for both of those. So when I use this one, I want to look for hypotenuses that will help me get the same results. So here I can do C and I can do, let's take a look at these two right here and using that hypotenuse idea. So what I can do now is I can take and I can do, here's my hypotenuse, let's use this one, and that's C. And that's going to be over B, which is the short leg of this guy. So I have C over B. Then let's take a look at this short guy right here. Okay, so then here my hypotenuse is B, so I'm going to put that there. My short leg is X. So you notice, again, I have those B's sitting across from each other. Another option you can use to set these up is your hypotenuse over your long leg. So let's take a look at what that would look like in reference to our big triangle. So for our big triangle, I have C as my hypotenuse, and I have A as my long side. Then if I take a look at this guy, A is my hypotenuse. So I'm going to put A here, and then I'm going to put my long side, which is Y. So you're probably wondering, Miss Hummer, how on earth do I decide which triangles to use? You want to pick ones. Notice how the long side of this triangle corresponds to the hypotenuse of that triangle. That's why I picked those two, so I could get those opposites going there. So that's why I did that. Let's take a look at some examples of applications of this guy. So find the values of x, y, and z. Okay, well this can look really intimidating. So that's why I like to go through and I like to make my 3 triangles. So I'm going to make my long, short hypotenuse, long, short hypotenuse, long, short hypotenuse. Remember my right angles are down here. So for the big triangle, my short side is y, my long side is z, and my hypotenuse is 20. For my medium triangle, which is right here, my short side is the altitude, which is x, my long side is 20, and my hypotenuse is going to be z. Okay? Oh, I'm sorry. For this hypotenuse right here, we need to do 20 plus 5 because it's going the whole length. So this guy right here should actually be 25. Next, let's take a look at this little triangle. So for this little triangle, my short side is 5, my long side is x, and my hypotenuse is y. And I need to find x, y, and z. So let's go ahead and let's take a look at that. So what I notice is I have x as a short side here and x as a long side here. So what I'm going to do is I notice that long side and short side of both of these triangles, I have numbers. So I'm basically going to set up a proportion like I did with similar triangles. So I'm going to take of this triangle, short side over long side. Then of this triangle, I'm going to take my short side, which is 5, over my long side, which is x. So what I notice now is that I have these x's, and they're sitting across from each other. So I correctly set up that geometric mean. So now I'm going to cross multiply. X times x is x squared. 20 times 5 is going to give you 100. So to solve for x, you're going to take the square root of both sides, and you get that x is equal to 10. So x and 10 are the same thing. So I'm going to go ahead and fill in the values that I know. So this guy right here now is 10. This guy right here now is 10. So I'm taking a look at this triangle. I have 2 values. I have 10, I have 5, and I need to know why. Well, here's the great thing. Okay, I can use the Pythagorean theorem now because it's a right triangle. So I take my side squared, so 5 squared plus 10 squared is equal to y squared. Remember, your 2 legs squared is equal to the hypotenuse squared. So 10 squared is 25. 5 squared is 25. 10 squared is 100. And that's equal to y squared. So now I have 125 is equal to y squared. So then I'm going to take the square root of both sides. The square root of 125 is 11.18. Okay, then when I look at this next triangle right here, I notice that now that I plug in 10, I have 10 and I have 20, and all I have left to find is z. That's not so bad. Okay, so what I have is I'm going to have 20 squared plus 10 squared is equal to z squared. Again, using that Pythagorean theorem, now I don't have to use that proportion anymore. 20 squared is 400. 10 squared is 100, and then we have z squared. So we get that z squared is equal to 500. So now I'm going to take the square root of both sides, and I get that z is equal to 22.36 when you take the square root of 500. So now I found my x, my y, and my z values. So I'm going to go ahead and stop this video here, and I'm going to continue on part 2.